In the last video, we talked about using factoring in square roots in order to solve a quadratic equation. However, not everything can factor. Something like x squared plus 3x plus 3, if we tried to use our traditional method, we could subtract a 3x over and subtract a 3 over, but now we would need two numbers that multiply to be negative 3 and add to be negative 3, and those numbers just don't exist. So we need to use a different method. And there are two different methods we could use here. Completing the square, which is everyone's enemy when it comes to math, or quadratic formula. So while we won't specifically talk about completing the square here, it is important to note that the quadratic formula comes from completing the square. If we take a general quadratic equation, like ax squared plus bx plus c equal to 0, and actually perform a completing the square operation, we end up with our quadratic formula, which says negative b plus or minus the square root of b squared minus 4ac all over 2a. So while the completing the square process can be very tedious, it is important to note that it does have its place because it's where these formulas come from. They don't just show up out of nowhere. They do have the beginnings in completing the square. So now that we have the quadratic formula, let's actually use it. The first thing we need whenever we do this is we need to know a, b, and c. A is always the number in front of x squared, in this case 1. B is the number in front of x, in this case negative 3. And c is our constant, the one with no x's, in this case also negative 3. So the quadratic formula says negative b. So negative 3, that's just positive 3, plus or minus the square root of b squared, so negative 3 squared, minus 4 times a, which is 1, times c, which is negative 3, all over 2 times a, which is 1. And from here we can just do some arithmetic. Negative 3 times negative 3 is positive 9. Negative 4 times 1 times negative 3 is positive 12, all over 2. Well, 9 plus 12 is 21. So we have 3 plus or minus the square root of 21 over 2. We do like to reduce our square roots most of the time. However, 21 is just 7 times 3, so we can't actually pull anything out there. So we're done. Let's look at another example. 9x squared minus 11 equal to 6x. Just like when we were factoring, we do want everything on one side of the equation. So we'll start by subtracting the 6x over to get 9x squared minus 6x minus 11 equal to 0. Now in this case, a is 9, b is negative 6, and c is negative 11. So we can start to use our formula. Negative b, which is negative 6, or just 6, plus or minus the square root of b squared, so negative 6 squared, minus 4 times a, which is 9, times c, which is negative 11, all over 2 times a, which is 9. And now we get the job of simplifying. Well, we know that negative 6 times negative 6 is 36. And this next expression is a bit more complicated. We probably don't know what 4 times 9 times 11 is in our head, but we can use a calculator and realize this is positive 396 over 18. And now we have 36 plus 396, which gives us 432 over 18. This one looks a lot more complicated, and like I said in the last example, we usually want to do something with these square roots to simplify them. So let's see if we can simplify it. Usually when we want to simplify square roots, we try to think what multiplies to be this number. However, 432 is a really big number. It may be hard to know exactly what multiplies. So let's start thinking what divides 432. Well, we know that 2 divides 432, and that leaves us with 216. Once again, we know that 2 divides 216. That leaves us with 108. 2 also divides 108, which leaves us with 54. Once again, we can pull out another 2. This leaves us with 27. And we know 27 is 3 times 9, and 9 is 3 times 3. So in square roots, we like to pull out pairs of things. So I see this pair of 2's, a pair of 2's, and a pair of 3's. So we actually pull something out. We have a 2, and a 3, which would be a total of 12. And this 3 down here at the bottom is left over, so it's what's going to stay underneath our square root. Whenever we simplify, we need to simplify in all 3 locations. So 6, 18, and 12 all simplify by 6. That would be a 1, plus or minus 2 root 3 over 3. So now we have the most simplified answer possible. Let's do one more. In this case, we already have 0 on one side. So A is 2, B is -5, and C is 3. So our formula says negative B, -5 is +5, plus or minus the square root of B squared, so -5 squared, minus 4 times A, which is 2, times C, which is 3. All over 2 times A, which is 2. As we simplify this, we know that -5 times -5 is +25. And 4 times 2 times 3 is 24. All over 2 times 2, which is 4. Well, 25 minus 24 is just 1. And we know the square root of 1 is just 1. So now I have 5 plus or minus 1 over 4. Well, we can start simplifying this a lot more now. We have 5 plus 1 over 4 and 5 minus 1 over 4. Well, 5 plus 1 is 6, and 6 over 4 is going to reduce to 3/2. 5 minus 1 over 4 is 4 over 4, which is just 1. So this time I have 2 answers, 1 and 3 over 2. These actually worked out to be a lot nicer than our last 2 examples, and the reason why is our original function, our original equation here, could have factored. So it's not impossible to use this method even if you can factor. It'll still give you the right answer. It's just that you'll actually be able to take a square root instead of leaving this ugly square root in the middle of your problem.